In your treatment example, could you do anything, or what would you do if you only had these process variables for the treatment group, and you wanted to estimate a between group treatment effect, but then look at the process only for the treated individual? So you don't really have data for the control group.
All right. So you don't have a control group.
You have a control group, but you don't have data, almost time points. You only have a
Or you
pre
only
and
have
post
ESM
score.
data for the treatment group?
Yeah.
And then prior and post to treatment, or?
Yeah, pre and post for both groups, but no repeated measures of the positive and negative affect for the control group. So you only want to look at the process of folks who are going through treatment, but you want to include that in a model so that you can link those processes to change.
I'm not sure I understand. Sorry. So you have two groups. So what have you measured for the control group if you don't have the repeated measures?
You don't have anything.
You don't have anything?
No.
So then you have no control group.
But you have the outcome variables. You have did they change on the outcome? So the depression scale, pre and post.
Oh, so that would be
But
like
the
a
positive-
between person. A between person variable. So in the treatment model that I discussed, like this one, as you see, the only predictor that I have is group at the between person level. I only have group. And I predict the means and the mean and the autoregression and the random slope here. So these are things that come from the intensive longitudinal data. So if I only have intensive longitudinal data for the treatment group, they would not be here. Yes. So I could.
Could they be
I don't
only at the
So I mean, and I don't have
within?
another between person variable here now, but of course we could have something like depression prior to everything, and that could be a predictor here in this part of the model and also here. But group wouldn't be a predictor now then, you know, because group, you cannot predict the mean of this intensive longitudinal measurements if there were no measurements at all.
Mm-hmm.
So I mean, it would be basically a different analysis.
Yeah.
Yeah.
My side.
Hi.
Hi.
So I'm actually interested in the coding of that group variable. Is it dummy or effect?
Which one?
The group.
The group variable is a dummy variable, yeah. 0, 1.
So if that's the case, and I may be misunderstanding the model, but does that mean that the time effect is conditional on the group coded 0?
Yeah. Yeah.
Okay.
Yeah.
So we'd want to effect code if we want to see average
Yeah.
and then swap.
Yeah.
Okay.
Yeah. Yeah. So yes. So I don't have an interaction here between time and group. I get.
Or is that baked in? 'Cause
Yeah. So so this would tell us, you know, whether there was a change in the mean, for instance, due to being in the treatment group, and then of course this is the change in mean you expect if this is 0. So yeah.
You can hand over the microphone to the right.
So with the example we were going over on slide 53, I see that
Which slide? Sorry.
53.
53.
So the data was collected 6 days, 10 beeps per day, and so we averaged across days for negative affect, correct?
What do you mean with?
I guess.
Oh no! I'm using all the 6 or the 10 beeps per day. Those
Okay.
separate variables, yeah,
And
or
so-
separate records, yeah.
Okay, and so I'm wondering with that, how did we create the lag? Because I know that on one of the slides we just do the lag with the
Yeah.
parentheses
Yeah.
and the one.
Yeah.
So
So here the problem is before we had daily diary data, then it's like very easy to say, okay, we have a time variable that's just day, and then we use the grid 1, you know, that's like so. When you have data, ESM data, you have to decide on the time scale that you're looking at. Here what I did was, so I did it in SPSS. I had a variable that says this is the day, and then this is the time within the day. And I combined the two, and what I did was it ended up with a variable that represents the number of hours since we started measuring. So it took a little, if anyone wants to, I'm totally willing to share the code. I mean, and I'm sure you can do it in other programs as well, but it's you just have to fiddle around a bit. But then you have this hours since the beginning, and then when I had to decide on the t interval, I chose 1 again. So the results that we get for the lag relationships are about a lag of 1 hour. Yeah. And so this also means if you at some point have a measurement maybe at 10 o'clock in the evening, and then the next measurement is at 7 o'clock the next day, there will be just like missing records, So basically, you don't have to worry that the first measurement of a day is regressed on the last measurement of the previous day, because there's so much missing in between that the effect will basically have disappeared. And this is another thing that, I haven't really discussed, but so it's the way this regression happens is not the same as it's happening when you are doing it with multi-level software, where you just create this lag predictor and then regress the outcome on the lag predictor. But it's using techniques from time series analysis, like the Kalman filter and state space modeling, where basically what is happening, this is the way I understand it, but then when Theo explained it to me, it was like slightly different, but it comes down to the same point. So what is happening is that you have your negative effect at a particular occasion. Based on the phi parameter that the Gibbs sampler is using, is making a prediction of the next occasion. If there is an observation, then the prediction will be updated in light of the observation. And then it will use this updated version to predict the next occasion. If then there is a missing value, because the person didn't answer it, or because the grid that we're using, it cannot update the prediction. So it will just use this prediction to make the next prediction. And if there's a whole string of missings, it will just continue to use the previous one, and it will actually go towards the mean of the person. So in this case, because it's centered, it will just go to 0. So that's basically what's happening.
Regarding scoring the time variable, if you have a timestamp in your data, day, hour, minutes, seconds, can't one use Excel to create a continuous time variable from that?
I assume you can do it with the define command in Mplus. I mean, you're essentially adding 2 variables, right?
Sure.
Can I ask
All
one
right,
more?
next question.
Can I ask one more really quick question? So,
Okay, but just one more.
Okay, sorry. For the mediation analysis, we noticed that the outcome was also centered, and so I was wondering if you could talk about that a little bit.
Yeah, I guess, I didn't have to center the outcome variable, but it was helpful to center the predictor, and then, to make sure that they are, I don't know. I guess I shouldn't have to do that. Yes. So that would be the answer. So centering the predictor is helpful because then the intercepts are actually the means, but for the random effects. But then centering the outcome, it's not really necessary. Or maybe it's actually not a good idea. Yeah.